Hi folks, welcome to our second video of this second week of the class. We're going to pick up where we left off with moments. So last time we talked about having like a diving board or some beam and a force acting on it. All right, and how that created a moment or a torque around some point A. So let's call this force F, but let's change the geometry a little bit. All right, we're going to take the same setup, rigidly attached wall. We're going to take the same beam, and we're going to take the same force, only we're going to have it come in at an angle. Same magnitude force. And we have that same point A here. Now, will both of these have the same moment about A? And clearly, you see that that's a no, right? I mean, F here is perpendicular to the beam. So D is the moment arm. But here, F is not perpendicular to the beam, so the length of the beam is not the moment arm. Remember, it's the perpendicular distance from the force to the point of interest. In addition, the beam, in terms of just opposing forces, has to react to just a vertical force here, whereas here it has to react to both a vertical and a horizontal force. Okay, so let's take a look at this. Let's just get this left one out of the way real easy. We already did that one. If this is D, this is what we've been calling this. All right, then the for this one, the moment about A is going to be just force times distance, right? Because they're perpendicular here. This one's different. All right, we have some angle that we'll call theta with the perpendicular. Now remember, D is the minimum distance between A and the line of action of the force. All right, so the line of action of the force, remember, goes in the direction of the force. So the distance, the perpendicular distance in this case is going to be right about here. Right. This is the moment arm for this case. All right, and it's not going to be the same as D. All right, so let's see. We got some triangle business going on here. This angle here is also going to be theta. So that means that this distance here, let me get another color because this is getting confusing. Okay, this distance, the actual moment arm, okay, is going to be d times the cosine of theta. Right? So in this case, the moment about A is going to be the force d cosine theta, because we're keeping the variable d the same. Variable d is the length of this beam. All right. So let's look at a different way. We've got the same beam, got the same force. We got an angle, same angle, theta, and we still have this distance d. Okay, so another way to look at this is to break the force up into components. All right, you break it up into its components, and then do this two separate problems. Look at the effect of one component, what the moment created by one component, then the moment created by the other component. So if we're going to continue the triangle here, we have f, and this is theta here, f sine theta, and this is f cosine theta. So let's look at this vertical component first. F cosine theta. Okay, so the moment due to f cosine theta equals f cos theta times d. Right, because that's for f cosine theta, that's the perpendicular, so d is going to be the moment arm. For the moment due to the perpendicular component, f sine theta, or the horizontal component, it's horizontal. There is no moment arm. All right, so the moment for this one is f sine theta times 0. Okay, it's never going to intersect with d. All right, so there's no moment arm. So that means that the total moment about A is going to equal the sum of these two components, the sum of f cosine theta times d plus 0, because this one is obviously 0, just for completeness sake. So it's going to be f d cosine theta. Okay? Which is the same as we found this way. And it has to be. Right? Both methods are legitimate, so it has to be the same both ways. Okay. So, recall that in 2 dimensions we have just 2 directions for moment. So in 2D, moment can only be clockwise or counterclockwise. And by definition, clockwise is considered negative, and counterclockwise is positive. Okay. So therefore moment is a vector since it has direction, m bar. All right. Okay, that's it for this one. I'll be back with taking this to 3D. Bye for now.